Dear viewers, in this lecture, we will be seeing how to analyze a simply supported truss using method of joints. So, the problem is determine the force in the members of the truss shown in figure using method of joints. So, we have support A, support D, these are the joints B, C and E. Load of 2 kN and 4 kN is applied as shown in the figure. This is 60 degree, 60 degree, and this distance is 3 meters. So, in case of simply supported truss, first we need to find the support reactions. So, the support reactions shall be found using the basic equations of equilibrium. First, let us use sigma V equal to 0 upward positive. Sigma V equal to 0 upward positive. So, we have RA, that is reaction at A upward, RD upward, RA plus RD minus 2 minus 4 equal to 0. Therefore, RA plus RD equal to 6. This is the first equation. Then using sigma M equal to 0 and taking clockwise moments as positive, and taking ones of all forces about A, we have this 2 kilonewton. So if you produce the line of action and this is 60, this is 60, therefore this will act at the center, that is 3 by 2, 1.5. So 2 into 1.5, this is clockwise, 2 into 1.5, and 4 into, so this will act at the center because this is 60 degree and 60 degree. So here 1.5 and here we have 3. So 4.5 meters. So this will also produce clockwise moment, and this RD will produce anti-clockwise moment. So minus RD into 6 equal to 0. Therefore, RD will be getting the value as 3.5 kilonewton, and hence RA will be equal to 2.5 kilonewton. So finding the support reactions is equal to finding reactions in a simply supported beam. So to find reactions, always use the equation sigma V equal to 0 upward positive and sigma M equal to 0 clockwise positive, and find the support reactions. Next, we need to consider the free body of every joint. So consider joint A. So joint A, we have this upward reaction of RA 2.5 kilonewton, and at joint A we have this member AE. Therefore, the force in member AE we are assuming as a tensile force. So a tensile force should leave the joint, and we are assuming the force in AB as FAB, that is also tensile. So it is better to assume the unknown forces as tensile forces. So this is the free body diagram. So a free body diagram is a diagram showing all the external and internal forces. So this is the external force, and these are the internal forces which are set up to resist the deformation at this joint A as well as this B and this joint E. So now we are going to use the equations of equilibrium at every joint. So considering the joint equilibrium using sigma V equal to 0, that is sum of vertical forces equal to 0 with upward positive. So here initially we have 2.5 is vertical and it is acting up, therefore plus 2.5, and this horizontal force will not give any vertical component, therefore we can leave this. This FAB inclined force shall be resolved along this axis. So vertically it shall be resolved. So we know that vertical components are always sin theta, horizontal components are always cos theta, provided theta is with respect to the horizontal axis. So if we resolve FAB, we'll be getting FAB sin 60, and while resolving, watch the direction of this arrow. So if you resolve, the arrow will move upward, therefore plus FAB sin 60. So 2.5 acting upward, so plus, and if you resolve this FAB sin 60 will also point upward, therefore plus equal to 0. Therefore, we'll be getting FAB equal to minus 2.89 kilonewton. Now we will use sigma h equal to 0. So sum of horizontal force is equal to 0. So this is vertical, so this won't come into play. This is horizontal and acting towards right. So towards right we are assuming as positive, towards right is positive. Therefore FAE will come. And similarly, any inclined force shall be resolved into horizontal as well vertical component. Vertical component we already considered while using sigma V equal to 0. Now if we resolve horizontally, so FAB cos 60. So FAB cos 60, and after resolving, see the direction of this arrow, where it will go. So if you resolve horizontally, this arrow will be pointing towards right, therefore plus. So FA is plus, then FAB cos 60, because all horizontal components will be cos 60, cos theta. So FAB cos 60 equal to 0, and FAB value you have here. So substitute the value of FAB, you'll be getting the value of FAE. So after getting these two unknown values at a joint, then write the result like this. Don't write the result in between before the procedure is completed at the joint. So we need to take the forces and we will write the magnitude as well nature. So FAB equal to minus 2.89. So minus indicates it is compression because a truss is predominantly mostly a tension member. Therefore, if minus comes, it will be minus is treated as compression. So minus shall be removed and it will be written as 2.88 kilonewton compression. And FA is 1.45 kilonewton. So this is plus therefore tensile. Then we shall go to the next joint. So the joint we need to go like this. So we have started with joint A. So the next joint to be considered shall be either B or either A. So while choosing the joint, this point should be borne in mind. That is, at any joint there should not be more than two unknowns because we have two equations of equilibrium, sigma V equal to 0 and sigma H equal to 0. Therefore, only two unknowns should be there available in the joint. So if we take joint B, here this side FBA, this side FBE, and this side FBC. So FBA we have already, FAB we have found, that will be equal to FBA we have already found. So for this will be one unknown and this will be one another unknown. But if we take a joint E immediately after A, this A is known, whereas this EB, EC, ED, there are three unknowns. Therefore, we can't go to joint E at this moment. So consider joint B where there are only two unknowns. So that's why we are going to next joint is joint B. So at joint B, draw the free body diagram carefully. We have external load of 2 kilonewton and we have force acting in the member BC. Therefore, that will be named as FBC and assumed as tension. And there will be a force in BE that will be assumed as tensile force FBE. And this FAB or FBA is already found it as 2.89 kilonewton compression. FAB is 2.89 kilonewton compression. This we have found in the earlier step. So the compression force should be marked like this. It should move towards the joint. That is, it should go and compress the joint. So this will be 2.89 kilonewton. Now, after drawing the free body diagram, you can use sigma V equal to 0 and sigma H equal to 0. So when you use sigma V equal to 0, start with already available vertical force. So this 2 is already vertical and acting downward, therefore minus 2. And this 2.89 inclined force shall be resolved vertically. This inclined force shall be resolved vertically. And this will not come into play as it is truly horizontal. So if I resolve this 2.89, so 2.89 sine 60 will be here, and watch the direction of this arrow after resolving. So after resolving, this arrow will move upward, therefore plus 2.89 sine 60. And if we resolve this force after resolving, it will be pointing downward and the vertical component will be FBE sine 60. Therefore minus FBE sine 60 equal to 0. Therefore if you simplify, you'll be getting the value of FBE. Then using sigma H equal to 0, we are going to apply sigma H equal to 0 at this joint. So using sigma H equal to 0 towards right positive, let us start with the already available horizontal force. This is horizontal, so this is pointing towards right, therefore plus FBC. And then this 2 will not come into play because it is truly vertical. This 2.89 can be resolved along the horizontal axis. So if you resolve 2.89, it will be 2.89 cos 60, and watching the direction of this arrow, it will move towards right, therefore plus 2.89 cos 60, and this FB can also be resolved along horizontal axis. So FB cos 60, and when it is resolved, this arrow will move towards right, therefore this also plus equal to 0. So substituting the known values, so here FB is known, FBC is unknown, so FBC can be found. So FBC is found as minus 1.7385 kilonewton. So now we can write the answers of finding the unknowns. So we can write FB equal to 0.577 kilonewton tensile, where FBC equal to 1.7385 kilonewton compression. Removing this sign, you can write as compression. So this will be the answer. FB equal to 0.577 kilonewton tensile and FBC equal to 1.738 kilonewton compression. Either you should use sign or nature. Then we can go to joint E. So joint E, this AE we have already found as 1.4 kilonewton tensile. So for tensile force should be marked moving from the joint or leaving the joint. And this force we have found FBE is 0.577 tensile. Therefore, you can mark as 0.577 kilonewton tensile. And this is unknown. This is unknown. So unknown forces are assumed as tensile. So this is FEC and this is FED. This angle is 60 degree. This angle is 60 degree. So now use sigma V equal to 0 upward positive. So sigma V equal to 0 upward positive means these two are the inclined forces which shall be resolved vertically. This will not come into play and this will not come into play because they are truly horizontal. So when FEC resolved vertically, FEC sin 60 and the arrow will move upward. Similarly, if this force is resolved vertically, the arrow will move upward. Therefore, FEC sin 60 plus 0.577 sin 60 equal to 0. So FEC sin 60 points is equal to 0, from which we can find the value of FEC. So FEC equal to minus 0.58, and using sigma h equal to 0 towards right positive. When you resolve horizontally, there are already horizontal forces. So first write them. FED is moving towards right, therefore plus this 1.45 moving towards left, therefore minus 1.45. This shall be resolved horizontally. This shall be resolved horizontally. If you resolve this, it will become FEC cos 60, and it will move towards right. The arrow will move towards right, and if this is resolved, this will be 0.577 cos 60. Arrow will be moving left, therefore minus. For minus 0.57, so cos 60. So if you simplify, you'll be getting the value of the substitute the known values and substitute the find the unknown values. So FED, you'll be getting this value. Then considering joint D. So considering joint D. So finally, we should write the results. If it is plus, it will be tension. Minus, remove minus in and write test compression. So here it is tensile. Now consider joint D. The free body of joint D will be, we have upward reaction 3.5 kilonewton here, and this force we have already found D, we have already found 2.03 tensile, marked as tensile. This is the only unknown force FCD. So FCD can be found by using either sigma V equal to 0 or sigma H equal to 0. So if you use sigma V equal to 0, first write the force which is already truly vertical, therefore 3.5 moving upward, therefore plus, and this can't be resolved because it is truly horizontal. This is resolved. When this is resolved, FCD sin 60, and after resolving, the arrow will be pointing upward, therefore plus. So 3.5 plus FCD sin 60 equals 0, from which FCD can be found. It is minus 4.04. Therefore, after finding all the forces, we need to mark the forces in the members along with nature. For example, FAB is 2.88 kilonewton compression. So a compressive force should move towards the joint. So if you take this side, it should move towards the joint. If you take this side, it should move towards the joint. So this is the notation for compression force. Similarly, here we got 1.738 compression. So it should point towards B as well. It should point towards C for compression. Here we got tensile force. A tensile force should leave the joint. So with respect to B as well E, it should leave the joint. So this is tensile force. This is compression force. This is tensile compression. So mark the magnitude along with the nature according to the sign. So if it is plus, it is tensile, and minus, if it is compression. And compression force should compress the joint or move towards the joint. Tensile force should leave the joint. So thank you all for your patient listening. Kindly subscribe our channel to reach everyone the Learn Easy program.